If you strip modern survival down to its weakest point, it is not shelter or food. It is power. The moment batteries die, radios go silent, navigation tools fade, and even light becomes a luxury. That problem is not new. Long before lithium cells and sealed electronics, soldiers faced the same reality under fire, in trenches and behind enemy lines. What they relied on was not magic, and it was not crude guesswork. It was chemistry so simple it could be rebuilt from scrap. Rust, vinegar and basic metal became a reliable source of electricity when everything else failed. This method never powered cities, but it kept lights glowing long enough to read maps, signal silently, and survive nights when darkness could get you buried. Today, this forgotten trick still works exactly the same way, and understanding it changes how you think about power in extreme situations. Why soldiers needed power solutions that did not rely on supply chains. During prolonged conflicts, especially in the early and mid-20th century, soldiers learned quickly that issued batteries were unreliable. Cold drained them, moisture destroyed them, and resupply could take weeks or never come at all. Radios, signal lamps, and small electrical devices were useless without a power source. Field manuals and informal knowledge passed between units emphasized improvisation. Vinegar was common. Rust was unavoidable. Scrap metal was everywhere. The question became how to turn decay into function. The answer came from basic electrochemistry that predates modern warfare by centuries. How rust and vinegar create electricity without moving parts. At its core, this method uses a simple galvanic reaction. When two dissimilar metals are placed in an acidic solution, electrons begin to flow from one metal to the other. Vinegar acts as the electrolyte. Rusted iron serves as one electrode, while copper or another stable metal serves as the other. The rust itself is not the power source, but its presence increases surface area and improves the reaction. The result is a steady, low-voltage current. It is weak by modern standards, but reliable and repeatable. Soldiers did not need bright light. They needed enough power to glow a filament, activate a tiny bulb, or later run a basic indicator. How soldiers actually used this hack in the field. This was not theoretical chemistry. Soldiers assembled these makeshift cells inside canteens, jars, or even helmet liners. A strip of rusted steel and a piece of copper wire were submerged in vinegar or any acidic liquid available, sometimes even wine or fermented water. Multiple cells were chained together to increase voltage. The output powered low-draw lamps, test equipment, and improvised signaling devices. Because there were no moving parts, nothing wore out quickly. As long as the liquid remained acidic and the metals were intact, the cell kept producing power. Soldiers trusted it because it did not rely on precision manufacturing or fragile components. So, why does modern science still respect this method? Well, modern batteries, they're more powerful, sure, but they're also much more complex and honestly a bit fragile. The old rust and vinegar cell, though, operates on these fundamental principles that just can't be disrupted by cold electromagnetic interference or even age. It doesn't degrade in storage either, since you only assemble it when you actually need it. That's why, even now, similar electrochemical principles are still used in emergency power demonstrations and educational labs all over the place. This isn't about nostalgia, it's just pure physics. When the infrastructure collapses, simple reactions like these often outperform the advanced systems that depend on sealed environments and tight factory tolerances. Now, let's talk about how this knowledge applies to modern survival and preparedness. For folks interested in survival, this technique really changes the way you think about power. Instead of hoarding batteries that eventually expire, you end up stockpiling understanding instead. Vinegar, for example, stores pretty much indefinitely. Scrap metal? It's everywhere. Copper wire can be salvaged from abandoned electronics, which is handy. With just a bit of basic knowledge, light actually becomes a renewable resource, not something that's going to run out. That's especially valuable in long-term grid-down situations where resupply just isn't an option. And, these same principles can power small sensors, emergency radios, or those low-energy LEDs that are made for off-grid use. All right, so how do you adapt this principle safely and effectively today? Modern application, it improves reliability without changing the actual chemistry. Using insulated containers, for instance, prevents shorting. Pairing iron and copper, well, that maximizes your voltage difference. And if you connect multiple cells in series, you can increase the usable output quite a bit. LEDs nowadays require far less power than those old historical bulbs, which actually makes this method more effective now than it ever was before. But the key, really, is understanding the limitations. This isn't a replacement for a generator. It's a survival light source, a signaling method, and a way to keep basic electronics running when everything else, just fails. Why did this hack disappear from common knowledge? Well, as mass-produced batteries became cheap and abundant, improvised power just faded from training. Convenience, you could say, replaced resilience. Soldiers no longer needed to understand how electricity worked, only how to replace a cell. That shift, it created dependence. When systems fail, the knowledge gap becomes dangerous. What once was standard improvisation became a forgotten craft. Yet the chemistry never stopped working. Only the memory of it faded. So, why does history keep offering better answers than we expect? The rust and vinegar light hack, it's not just a curiosity. It's proof that survival knowledge evolves both forward and backward at the same time. When modern systems collapse, the past becomes relevant again. Understanding these techniques doesn't mean rejecting technology. It actually strengthens it. The best survival strategies combine ancient principles with modern efficiency, creating systems that work when nothing else does. If this kind of forgotten knowledge matters to you, go ahead and subscribe to the channel and share this video with someone who believes power only comes from factories. History solved more problems than we give it credit for, and the solutions are still waiting to be used. The final siren.